Three-phase alternating current is based on magnetic phenomena. To understand three-phase alternating current, we shall first see how it is produced, then look at its characteristics, and finish by looking at unbalanced current. In a three-phase alternator, a magnet rotates around an axis. Three identical windings are regularly spaced out in the fixed part of the three-phase alternator. The windings are placed at 120 electrical degrees apart from one another. A three-phase alternator creates three single-phase alternative currents. During rotation, there are three 120 degrees sine wave shifts, the frequency of which is linked to the magnet's velocity. Sine waves appear out of synchronization on the chart. This is called wave shift. As the North Pole cannot be opposite all three windings at the same time, this creates a shift of 120 electrical degrees between each sine wave. With three windings, there are 6 wires in the alternator, 2 per winding. The regularly spaced windings means that the sum of the three currents is always 0. For example, if one sine wave is plus 0.9, one is 0, and one is minus 0.9, the current is equal to 0. It is therefore possible to link one end of each winding to a common point called neutral, shown here in orange. In this case, electricity only flows through 3 wires, thereby significantly reducing costs. These 3 wires are called phase 1, phase 2, and phase 3. Each wire supplies a single-phased alternating current. They all have the same frequency and the same magnitude, but are 120 degrees or 2 pi over 3 radians apart. In the standard case where 50 Hz is used, this means that the waves are 6.5 milliseconds apart. The system is then said to be balanced when the 3 signals are identical and are regularly spaced apart. In reality, the system can become imbalanced. Most of the time, this imbalance is reflected by one of the signals and has a greater magnitude than the other 2. The malfunction of powered equipment can be observed, as can overheating in some part of the electricity network. Generally, an assessment is carried out by measuring the voltage between each phase torque. If these are different from one another, then the system is imbalanced. The reasons for this may be a problem with supply from the energy supplier, the deterioration of a wire or electrical equipment, a poor electricity connection. What you need to remember about three-phase alternating current. A magnet rotates around an axis, and 3 windings are placed 120 degrees apart from one another. A three-phase alternator creates 3 single-phased alternating currents with the same magnitude shifted by 2 pi over 3 radians. The system is called balanced. At any given time, the sum of the 3 alternating currents within the same alternator is equal to 0 amperes. This is the neutral. Electricity flows through 3 wires called phase 1, phase 2, phase 3. The system can sometimes become unbalanced, which leads to malfunctions of powered equipment.